Okay, over the next few weeks, we will be concentrating on the Law of Indices. Today's video, we are going to be giving you an introduction on what kind of things you need to know. Okay, so let's get started. For instance, let's say I had this particular equation. 5 by 5 by 5 by 5. It's very long, and we can actually state this same equation in a more simplistic terms as 5 to the power of 4. Now we get this because the common figure here is the 5, which is coming from here. Okay, and there are 4 of them, and that's why we've written here at the 4. This particular way of presenting an equation is called the expanded form. Okay. You will need to know these terms, so it's best if you understand what it's meaning now. Now, if we didn't want to express it in an expanded form and be more concise, we would be calling it the index form. So, to be more informative about what our figure actually means, this number 5 here is known as the base. Sometimes you may actually hear it as the product. Okay, so if you ever see that or someone's asking you the product, they're referring to this bigger number here. This number here, it is known as the index, but sometimes you may hear it as power or exponent. They essentially mean the same thing though. You will need to understand and be able to recognise those terms though. If we were to compute this particular equation, so 5 to the power of 4, we would get 625. Now this number is known as the basic numeral. Okay, so it's the answer. Sometimes in maths though, we don't always have numbers. So instead we have letters that represent numbers, and often these numbers are unknown. So sometimes you will see, say that again, it's not that clear. So you might see x by x by x by x by x. Again, we recognise that this is probably not the most efficient way to say x. Remember, this part here is the expanded form. Expanded form, just as it is up the top. Now, for us to simplify this term, it would be x, because remember, it is the base product. Okay, and how many do we have? We have 1, 2, 3, 4, 5. So it's x by the power of 5. Okay, so these, is x. Okay. So what we need to do now, okay, so now we have this x, it is, this number here is known as a pronumeral. Try and spell it right, there we go. Numeral. And this represents an unknown value. So whilst we are dealing with maths, we actually don't know that value, and that's why we refer it in a letter form. At this point, it's actually interesting to note that when we're dealing with powers, or indices I should say, you should note that any power of itself is equal to the original base number. What I mean by this, for example, a to the power of 1, essentially the answer is a, okay, because 1 by itself just produces the same. For example, 2 by 1 is 2, okay? So same if I had 5 to the power of 1, it would equal 1. Now we're going to move on to what is known as prime factorization. There will be another video talking about what actually is a prime number, but for this video I'm not going to go into it because it would be too long. It really warrants its own video. So, like before, we had index form and we had expanded form. What we're looking for now is what's known as the prime factor form. So, prime factor form. And basically, this is again just expressing a number in a different fashion. So, for example, we may be given the number of 12. And we want to express this number in its prime factor form, which is here. Okay? So, to break this down, we could actually be saying that in order to get 12, we could go 2 by 6. Note that this is starting to look like a tree. Now, you can't have 2 is the prime factor of 2. So we can't break that down any further. But 6 we can. So another way we could state 6 is 2 by 3. So if we then pull this down to 2 by 3, you would find that the answer of these 3 digits equals 12. Which, funnily enough, is the number you started with. So we know that we are correct. Okay, so let's have another go with a bigger number this time. So this time we're looking for the prime factor of the number 108. Now, this is going to look like a tree. So what I would do to try and remember what prime factor form is think of a tree. Now, what we could do, because it's 108 is an even number, we could actually re-express that number as 2 by 54. Okay, so if you're not sure, grab your calculator out, put in 2 by 54, and you will get 108. Again, 2 is a prime number, so we can't prime an already prime number. However, we can for 54. So how can we say this? We could say 2 times 27. If we put that in our calculator, you would find the answer would be 54. Again, we can't do anything with 2, but we can with 27. Now, because it's an odd number, we can't times anything by 2 because it's odd. But we could times it by 3. 3 by 9 is 27. 3 is a prime factor of itself, so we can't use that, but we can do 9, which is 3 by 3. Now, if we bring this number down, and this number down, you would find the answer would be 108, which is exactly where we started from. So give that a go. Follow it through with me, replay the video if you need to, and we'll discuss more in class.